Hello and welcome to another video on the Mathematical Fundamentals, a course from Brilliant.org, a North American online educational platform for profit. That the whole purpose of this series of videos is to update and keep up the pace, as well as see what is the value from this course, which is going to provide us essential tools for mastering concepts like algebra, number theory, and logic. And I'm looking at this course as a way to also improve my logic thinking in English, which is very, very important. Because my thought process in Spanish is something that I cultivate, and thanks to my parents, that they helped me through that. Now I need to do that on English. So, Brilliant.org, after all, is this North American company that was co-founded by Sue King, and he presented that idea in 2011 to a series of investors and venture capitalists in one of them, Chamad Palihapitiya, invests in this idea, and he was a senior executive at Facebook from 2007 to 2011. And now he started a fund called Social Capital, where he invests in companies like Slack, for example. So that's great, that's interesting. And I also look at the different sections here, at least these first three sections. So the first is the generalized. And the value proposition of the mathematics is that is the practice of learning a lesson in generalize. In other words, the practice of generalized lessons is the core of the mathematics. And this is something very, very, very powerful to stick with, because I also look at a particular example when you know the sum of the first odd numbers, okay? So instead of you calculate, for example, the first or the first five odd numbers, or what is the sum of the first five odd numbers, which is 1 plus 3 plus 5 plus 7 plus 9, you, thanks to the geometry and some visualizations where you can see the patterns that arise, and from there you can create some basic or some general purpose or generalizations using algebra. So instead of calculating this, okay, manually, you save a lot of time to do that using this formula. And that's something beautiful. And again, especially if you come from context or in the Spanish context, where it's quite hard to see the value proposition of the mathematic, especially because you have to memorize all of this formula. And the whole point of this is that understand why this formula exists. And it's because they want to solve a particular problem that appear often, and the way to do that simply or faster is by using this formula. So again, just refreshing concept here and how important it is to, well, especially if you have to explain that perhaps to someone that is not in the field, new to the field, in simple terms, and also with some sort of visualization, which is something that they did. and using a real example of the arithmos, or the arithmetics, okay, which come from the Greek word arithmos, and arithmetike, it can be translated to the art of counting. And I want to emphasize this because, after all, is this the art of counting. Great. So, and when you want to know what mathematic, or the word mathematic come from, it comes from mathema, from the Greek mathema, which means learning. So mathematics can also be translated according to the etymology dictionary, the online etymology dictionary, is uh, that which is learn, what one gets to know. And that's the beauty of this. So regardless your condition, it'll be quite hard or more easy, but you can learn this. Okay, it's something that is available for all of us. Again, some of us will have more. The, some of some of us will be some of us that will be more challenging than others. But again, you can do this. So this is interesting. This is powerful. Uh, and this is the value proposition of the mathematic. And the value proposition of the mathematician is those that put at practice this learning, or in other words, is those that put at practice this to know why this pattern arises. And that's beautiful. Totally. Yeah. And that's totally beautiful. And that's totally beautiful. Yep. And that's totally beautiful, by the way. Yeah, and I make a huge pause here, because I just recap and take a time to pondering about this. It's like, this is awesome. This is beautiful. Uh, and also the reason I'm looking this is because I just want to have some sort of certainty, especially if you now live in Latin countries where, oh man, this is no man's land, or this is, yeah, it's like no man's land, you know, no man's land. So deal with it. Get ready. Okay, so this is the model one. Okay, the patterns and the generalizations, and we look at that by saw a particular pattern in arithmetic, the operations on numbers, additions, subtractions, multiplications, and divisions, and how, by looking at a particular problem, how can we generalize a lesson using algebra. And again, this lesson is something that often in mathematics, or in the real world, often you don't see that happening once. Otherwise, that's the reason why they call patterns. Okay? And okay. And then I look now that I know the value proposition of this, which is pattern, mathematics, the value proposition of mathematics, and the mathematicians, and how you can, thanks to the geometry, illustrate why this pattern arises. Okay, and now I look at rewrite, rethink, and redraw, which means that now I'm just gonna see uh, from this pattern that happens in the mathematical fractions called the fractals, which are the mathematic of fractions less than 1, and compound interest, the mathematic of fractions greater than 1. Look at these particular patterns and how by changing your perspective, in other words, like in this case we were looking is the patterns that arise by looking at the mathematical fractions less than 1, by looking them, and then how in so look at the mathematical fractions less than 1 and see what is the pattern that arises, and then look at the mathematic for the other side, and then look at the mathematic of fractions greater than 1 and look at the pattern that arises. So the whole point of doing this is changing your perspective. Is a powerful problem solving technique in math and in real life. So if you face a complex problem, facing a complex problem with the so often a complex problem with the right perspective suddenly make that straightforward. Make that straightforward, and that's the power here of perspective, which is the second course, or is the second section here in this course. So we're talking about is perspective, okay, and the use is the mathematical fractions. In this case, to look at the mathematical fractions less than 1, okay, and see where the pattern arise, which is fractals, and using again geometry, these visualizations, okay, and then now look at the mathematic of fractions greater than 1, okay, and be able to see that the pattern that arises, the compound interest. So just to be just to be quite technical here, okay, is that if we think number as shape, okay, so if we multiply by a fraction less than 1, it remove chunks in a regular way, smaller and smaller each time, ultimately producing a fractal. And a fractal is a concept that actually you can use to organize your life. And in my case, I'm using this to define is, well, what are the things that I would like to dedicate my attention? So, for example, in fitness and business and relationship, this as a way of building your life, okay? And the other is the compound interest. So now, by looking at the mathematical fraction, or in this case, if we think number as shape, by multiplying a fraction over than 1, we add chunks regular. We add chunks in a regular way, bigger and bigger each time, ultimately growing to infinite in an exponential way, producing this pattern called compound interest. And that's the beauty of this particular patterns. And the value proposition of this section was the perspective. Is that that's great, that's interesting, but by looking things from different perspectives, a complex problems with the right perspective can suddenly straightforward. And we look at patterns, we look at perspective. Again, I'm highlighting here verbs and actions, okay, that are relevant to here. So we look at patterns, we look at perspective, and actually put a practice that in real life, and also the logic, or in this case, is the relationship between your statement, okay, uh, yeah, so the relationship between your statement, Jesus, the relationship between the statement and the draw conclusion, and that's logic, okay, or mathematical logic. So thinking forward and backwards, especially when you read someone or when you hear someone, when you read or hear the statement of someone to draw some conclusions, okay, is something helpful to think. So when it comes to hear this kind of a statement here, okay, uh, yeah, when it comes to hear this kind of a statement, all right, is often. Mhm. So when it comes to hear this kind of a statement, to draw some conclusions, is useful to think forward and backward. Again, this is our tool sets that they are providing us. So thinking forward is that clarify what you can get, or in this case, thinking forward here is look at the thing that you can specify quickly. Here, thinking forward is this. So look at things that you can specify quickly, so you can understand the clues and then go on to reason about them faster. Again, is this? It can be a little bit more abstract here, and that's why we look, for example, at here the series of a statement. So put a practice a series of a statement, but again. So when you're going to analyze this statement to draw some conclusions, a practical tool is thinking forward, which is uh, look at the thing that you can specify quickly, so you can understand. Yeah, you look at the thing that you can specify quickly, meaning look at the true statement. Look at the true statement. So you can understand the clue, and then you can reason them about, and then you can reason about them faster. Okay, this is thinking forward, and then thinking backward is that, well, now that you do this, okay, now that you clarify the yeah, so now that you clarify what is true, or that you specify, uh, now that you look at things that you can specify quickly, okay, now enumerate all the possible answers and then filter down the list. So thinking forward and backward, okay, as a way to in the mathematical flow logic, reasoning about the statement quite challenging. Okay, or reasoning about them faster. And that's exactly, for example, when I look at the patterns. And yeah, by looking at the patterns, which like algebra, is that they are providing you, this kind of tool that can allow you to think of them faster or to get the outcome faster. So for example, instead of calculating is the first five odd, the sum of the first five odd numbers, so you have now this formula that you don't have to think about it. However, you know what you want, and that's exactly what you want. So this is beautiful, great, and I just want to make this quick recap, okay, about this and how helpful it is, especially to know and to pass through that, the patterns, the perspective, and the patterns, perspective, and statements, and draw conclusions. And what is the tools that you can use, especially to analyze this? So thinking forward is by looking at things that you can specify quickly, so you can understand the clues and reason about them faster. And the thinking backward is like, okay, so now you can enumerate all the possible answers, and then you can enumerate all the possible answers based on the data you receive, and then filter down the list. So the TLDR of thinking forward and backward is that by looking at the thing you can specify quickly and keeping all the possibility in mind, you can solve problems more effectively. And that'll be all for this video. Take care. Bye-bye.